All right, so for the first one, estimate the square root of 16.16 without using a calculator. So the key for this one is the word line. We're going to use a line. So the function is the square root. So for now, I'll just do the square root of x. And if you graph the square root of x, it looks about like this. And with the square root of 16.16, I don't know how to do that without a calculator, but I do know that the square root of 16 is 4. So then what I'll do is I'll use the 16, and where x equals 16, I'm going to find the equation of the tangent line. Hi, Angel, welcome.
How's it going, Perkins?
Do you have the worksheet?
I don't have the worksheet, but I'm writing it down on the notebook.
Well, I'll put it in the chat in case you want the worksheet itself. So I just put it in the chat. Okay, so because the square root of 16 itself is very easy, I'm going to use that. And then what I'm going to do is find the equation of the tangent line like this. And then, of course, the equation of a tangent line or of a line is y equals mx plus b. Whoa, what's it doing? Why is it doing that? Stop it. Please use another name. Oh, it thinks I was changing the name. Okay, stop it. So the equation of a line is y equals mx plus b. And then after I find that line, the equation of that line, then I could plug in the 16.16 to that red line. And then the difference between the actual square root function and the red line, there's going to be very little difference. Okay, so we start by taking the derivative. And the derivative of the square root function is 1 over 2 times the square root function. And then it's time to use this 16, so plug that in to the derivative. So it's going to be 1 over 2 times the square root of 16. And then the square root of 16 is 4. So it's going to be the slope equals 1 over 8. So 2 times 4. So now I know the slope of the red line, and the point is 16 comma 4. So x would be a 16 and y would be a 4. So now use the point slope formula. So y minus the y value of 4 equals the slope times x minus the x value of 16. And let's see, so on the right side, if you distribute the 1/8, that will be 1/8 x. And then when you distribute it over here, it's going to be 1/8 of negative 16. Well, 16 divided by 8 is a 2, so it's going to be minus a 2. And then to solve for y, just add 4 to both sides. So it's going to be 1/8 x. And then if you add 4 to both sides, hey, Angel, could you mute? Thanks. So then it's going to be plus a 2. And then the last part is what I was saying right here. Now plug in the 16.16 to the line, and it will be a good estimate for the square root. So it's going to be 1/8 of 16.16, and then plus a 2. So 16.16 divided by 8, well, 8 will divide into 16 2 times, so that means it's going to be 2.02, and then plus that extra 2. So my final answer is, it's 4.02. Now that I've done all of that without a calculator, now I'm going to use a calculator and see what the actual answer is, see how close it is to 4.02. So the square root of 16.16, and my answer was actually correct, at least to the first 4 decimal places, 4.0200. So that is a really good estimate. So then you might think, well, why do all of that work when you could just go like that? Well, one reason is what it's doing, and this is an idea throughout definitely sciences, well, engineering and computer science, is you have this complicated machine like a square root. And basically you're replacing it with a very simple machine, just y equals mx plus b. And it gives you a pretty good estimate. And as far as the computing power it takes you, you don't have to use a calculator. You could just use this. So if it was something like electrical engineering or computer science, when you use a simpler machine and it gives you a good estimate, that's a good idea because it takes less computing power, it takes less electricity, and then you could use a smaller battery, and then you could make the phone smaller, stuff like that. Does anybody have any questions? Okay.
I have a quick question.
Yes.
So the first part, you're just taking like a whole number, like a whole number
Right.
close to it.
Right. So whenever they would say the linearization, so if it was something like the cube root of 8.1, so use linearization to estimate what's the cube root of 8.1. Well, for one thing, the function would be the cube root of x. So that's the function you'd be taking the derivative of. And of course, cube root of 8.1, I can't do that without a calculator, but I could do the cube root of 8 equals 2. So then whatever number they give you, you're most likely just going to use the whole number that's closest to it. And then that would be something that you could do even without a calculator.
Cool, got it, thank you.
You're welcome. Next, where is the derivative equal to 0? Well, before taking the derivative, I'm going to graph it. So I end up doing the calculus and then also graphing the function all the time. Most of the time I do the calculus first and then graph it, but sometimes I want to do the graphing first. So I'm going to do that. So it's e to the x times sine squared. So it is e to the x and then times sine squared. And that means they should be in radians, yes. And then take a look at the graph. So in that part of the picture, I could see there would be 1, 2, 3, 4, 5, 6, 7. Oh, the little cursor stopped working. But there would be a lot of places where the derivative equals 0. So maybe I should have modified that and say, let's just go from 0 to 2 pi. All right, then for the derivative, this is a product, so use the product rule. The derivative of e to the x is just e to the x, and then leave sine squared alone, plus, for the next part, leave the e to the x alone, and then take the derivative of sine squared. So that means you have to do the squared part first. So do the power rule. The 2 goes down in front, and then subtract 1. So that's just going to be sine x. And then the chain rule will say, now you need to take the derivative of sine, which is cosine. And right now, I could even answer part B. Where is it undefined? Well, undefined will come from taking the square root of a negative. This doesn't have any square roots, so that's not a problem. Also, division by 0. And this doesn't even have any division, so that means that for part B, there's no answers for where the derivative is undefined. But where is it equal to 0? So this has e to the x, so that could be factored out. And then this has sine, and this has sine, so I could actually factor out both an e to the x, and then also a sine of x. And then what remains? Well, from this first one, it had sine squared. So if you factor out a sine, it still leaves a sine. And then for this one, there would be the 2, and there would be the cosine. So now that it's factored and equal to 0, then just set each factor equal to 0 separately. So e to the x equals 0. Sine of x equals 0. And then also sine of x plus 2 cosine of x equals 0. Well, for this first one, the e function, it never equals 0. So that one gives us no solutions. And then if you look at the sine graph and where it equals 0, that would be at 0 and then pi and 2 pi. So I think I'm going to make some space over here and then put my answers. So x equals 0, x equals pi, and x equals 2 pi. And then onto the third equation. How do I solve this? Anybody got any ideas? None? Well, when dealing with trig equations, one guiding principle is you should try to get just one trig equation. Somehow using trig identities or algebra, get it to be just one trig equation. Because if you could get it to be something like, sine x equals a half, which I'm not saying it is, it's not. But if you could get it to be something like that, then all you have to do is do sine inverse of a half. So how do we get this to be one trig equation? Oops. So what I could do is subtract sine of x from both sides. So it would leave 2 cosine of x equals negative sine of x. And then to get this to become one trig equation, divide both sides by cosine. So on the left side, the cosines are going to cancel, so it's just going to leave a 2. And on the right side, sine divided by cosine, that's tangent. And then I'm just going to take the negative sign. Okay, I'm just going to take the negative sign and transfer it to the other side. So then when does tangent equal a negative 2? So tangent inverse both sides. And then what's tangent inverse of negative 2? So my calculator right now is in radians. Tangent inverse of negative 2. Let me change that to be 3 decimals. So a negative 1.107. Now, negative 1.107 is not inside of the interval 0 to 2 pi, but here's basically what's happening. So here's negative 2 on the y-axis, and then I just graphed the tangent, very sloppily, but that's tangent. And if you go across, when does tangent equal a negative 2? Then that's going to be when x equals a negative 1.107. Well, if you want a positive answer, then just follow the negative 2 until it's over here. And then what will x be right there? Well, the period of tangent is equal to pi. So if you want to get from one branch of tangent to the next, then you just need to add pi. So that means this point would be negative 1.107 plus pi. Just do that right here, negative 1.107 plus pi. So that equals 2.035. And then there would be one more answer. Because if you extend the x-axis out and then draw tangent one more time, and then you continue the red line over, that would mean add on another pi. So this answer right here would actually be negative 1.107 plus a pi plus another pi, so that would be plus 2 pi. So if I add on another pi to that, then that equals 5.176. So now I'm done. I just need to write down the last two answers that I got. So also x equals a 2.035, and then also a 5.176. So now I'm going to go back to the graph and see if these answers look right. Because we only have an hour, I'm not going to check every answer. I'm just going to randomly pick one. And if 2.035 is correct, most likely I did the other ones correct. So I'm just going to test that one, 2.035. So then go back to the graph and type in 2.035, and then that should be a place where the derivative equals 0. So by looking at the graph, that's a maximum point. So that definitely is where the derivative equals 0. But if you notice, my calculator says dy dx equals negative 0.009. Well, that's because the 2.035 is just an estimate because I didn't write down all the decimals. If I would have written down all the decimals, then it would have been more precise. But that one, by looking at it, that's the maximum point. So that's where the derivative equals 0. Now that I look at it like that, that's sort of sloppy. Sorry. Does anybody have any questions? All right, then on to the next one. So this next one has a square root and a cube root. And it has a product of the square root with this cube root of x minus 1. So not only will we have to do the product rule, but then we'll have the derivative of the square root of x, and then later we'll have the derivative of the cube root of x. Well, this is a case where I think it would be better to go ahead and multiply this out first. So distribute it first, and then do the derivative after that. And even before I multiply it out, I'm going to replace the square root with x to the half power and the cube root with x to the 1/3 power. So then when I distribute, there's going to be x to the half times x to the 1/3. And when the bases are the same, then you add the exponents. So it's going to be x to the half plus 1/3 and then distribute the x to the half over here to the -1. So that's going to be negative x to the half. So how much is a half plus 1/3? You could do this way. So 3 times 1 is 3. 2 times 1 is 2. And then multiply on the bottom is 6. So that's going to be 5/6. So its exponent is 5/6. Okay, so that 3 steps of algebra is going to make taking the derivative much easier. Now take the derivative. So just use the power rule. So the first one will be 5/6x. So bring it down in front and multiply, and then subtract 1. So 5/6 minus 1 would be negative 1/6. And then do the power rule on the next one. So bring it down and multiply and then subtract 1. And then a half minus 1 will be negative a half. And then I'm going to rewrite it so that it doesn't have negative exponents. So the first one has a 5 on top and a 6 on bottom. And then it also has x to the 1/6 on the bottom. And then the next one has a 1 on top, a 2 on the bottom, and then x to the half. So there's the derivative. And while I have it in this form, I'm going to go ahead and answer B. So like I said, it's going to be undefined if you have the square root of a negative or if you divide by 0. And this has both of those in there. So because this one right here means the square root of x, that means that x has to be positive. And x cannot equal 0 either. So where is it undefined? If x, so the answer to this one is if x is smaller than or equal to 0 is where it's undefined. So for it to be defined, x has to be a positive number. Then for part A, when does the derivative equal 0? So just plug in a 0 right here. And then recopy the right side. So then what I would do is I would take this negative term and then I would move it to the other side so that the two fractions are equal to each other. So to save space, I'm just going to do it like that. So you move it to the other side, it becomes positive, and then the two fractions are equal to each other. Now there's two ways to proceed. One would be some people will just automatically say cross multiply. And you could do that, but that's going to cause you one or two extra steps that you don't really have to do. What you really need to do is get the x's on one side and the numbers on the other side. So I'm going to get the x's on the left side. And to do that, multiply both sides by x to the half. And then I'm going to get the numbers on the right side. So instead of 5/6, multiply by 6/5. So multiply by 6/5. So these numbers cancel. And then for the x part, since they're dividing, you need to subtract the exponents. So it's going to be x to the half minus a sixth. And on the right side, the red x to the half and the black x to the half are going to cancel each other out. And then this would be 6/10, or if you reduce it, it's 3/5. And then for 1/2 minus 1/6, you could get a common denominator. You could also go a half minus a sixth, and then go to math, change that to a fraction and reduce it, and it's going to be 1/3. So it means x to the 1/3 equals 3/5. And then the last thing to do to solve for x is cube both sides. So it's going to be 3/5 gets cubed. So 3/5 gets cubed. So as a decimal, it's going to be 0.216. So x equals 0.216, and that's actually the only place where I found the derivative equals 0. That was some good algebra. So now I want to graph it and see if that looks right. But when you graph it, always graph the original problem, even before we did any algebra. Just in case I made a mistake on the first step of my algebra, I need to graph the original problem. So that's the square root times the cube root minus 1. So that is the square root of x, and then times math the cube root of x, and then minus a 1, and it's in parentheses, all right? Then for the graph, so if you zoom in and zoom in, it looks like the derivative equals 0 right about right there. Right there when it turns red. There we go. And if you look at the x value, it's 0.216. Thank you, thank you. Got it. I love math. Okay, so the 0.216 was correct. Even gonna highlight it in yellow. I got it right. Does anyone have questions before I go on to the next one? Wow, we have 5 students this time on the Tuesday. That's a record for the Tuesday one. So for this one, I said, let's start with the graphing. So this one is x squared minus 3x over x squared plus 1. So starting with the graphing, y equals, put parentheses, x squared minus 3x divided by parentheses, x squared plus 1. And it looks like there's 2 places where the derivative equals 0. Right there at the bottom, which is going to be, looks like x equals a 0.721. And then up here, when it reaches the top, a negative 1.387. Now let's see if we could get those answers. So to answer the question, there's one minimum and one maximum. For this one, there isn't really any algebra that I could do to simplify it, so we're going to have to get the quotient rule and just start doing the quotient rule. Starting on the top, the derivative of the top is going to be 2x minus 3. And then just copy down the bottom, x squared plus 1. Next, it goes minus, leave the top alone, x squared minus 3x. And the derivative of the bottom will just be a 2x. And then for the last part of the quotient rule, just square the bottom. Now for the top part, I do need to multiply it out because there's going to be like terms that I have to combine. But for the bottom, there's no reason to multiply it out. Just leave it like that. Okay, so for the top, there's going to be 2x times x squared. So that's 2x cubed. Then there's going to be a 2x times a 1. So that's going to be just a positive 2x. And then distribute the negative 3. So there'll be negative 3x squared and then minus a 3. So there's the first part. For this other part, I need to distribute the 2x and then also distribute the negative. So 2x times x squared, that's 2x cubed, but distribute the negative, so it's going to be negative 2x cubed. Then there's the 2x times the negative 3x, so that would be negative 6x squared. But then you have to distribute the negative, so that's going to be positive 6x squared. And then combine like terms. Well, there's a 2x cubed that's positive and a 2x cubed that's negative, so they actually cancel each other out. As far as the x squares, there's a positive 6x squared and then minus 3x squared. So that leaves behind 3x squared positive. And then there would be the 2x just by itself, so plus a 2x. And then there would be the constant, negative 3. And then we're done with part B, finding the derivative. Then set it equal to 0. Well, whenever you have a fraction and it says when does it equal 0, all you need is the top equals 0. The bottom equals 0, that would be if it said when is it undefined. So we really just need the top equals 0, 3x squared plus 2x minus 3 equals 0. And then what's everybody's favorite formula from pre-calculus? Come on, somebody say it.
Quadratic formula.
The quadratic formula. When I teach pre-calculus, I think I do this like 143 times each semester. So negative b plus or minus the square root b squared minus 4 times the a, which is 3, and the c, which is negative 3. All divided by 2 times the a. And then before I type it in the calculator, I'm just going to simplify a little bit. So how much is inside the radical? So that would be 4. And then a negative 4 times a negative, that would be positive. And then I would put it as 9 times 4, so that's 36. So inside the radical, it's a 40. And then get the decimal answers. And hopefully negative 1.387 is going to be one of them. How better? So we've got negative 2 and then plus the square root of 40. And then put all of that in parentheses and divide it by 6. So 0.721, I think that was the first answer I got. And then just screen grab it so I don't have to type the whole thing again. And negative 1.387. And I'm pretty sure that's what the graph said. So 1.387, yep, that one's right. And then 0.721, that one's right. So where is the function increasing? Well, as it goes from this maximum point right here, then this part is decreasing. That's going down, going down, going down, going down. So otherwise it's going up. So this right side, it's going up. So all of that's going up, we're increasing. And on the left side, all of this is increasing as well. So it's everything on the left of that negative 1.387, and then everything on the right of the 0.721. So where is actually talking about an interval. So it would be the left side, which goes from negative infinity to negative 1.387. And then union with the far right side, which is 0.721 off to infinity. And that one is finished. Does anybody have questions on that one? Let's see, what else did I do? Oh yeah, related rates. So a water tank is a right circular cylinder. So cylinder means take a shape like, for example, a square, Post-it note, and then stack them up the same shape going up. That's basically what cylinder means. Take the same shape and you just stack it up. With this being circular, that means you're putting circles on top of circles on top of circles, like a stack of quarters. And then right means that it's standing upright. So it's not at an angle, but it's perpendicular to the ground. So it basically looks like a soup can or a 55-gallon drum, something like that. And whenever you have a circle, then you've got a radius. The other thing we need to know is, what's the height? So this thing is being filled with water. So I need blue for water. So let's say that the water is up to this level. So all of this is the water. So at that point, then we would call this the height. Next, cubic feet. Well, cubic feet means volume. So then we need the formula for volume. Well, if you do pi r squared, that's the formula for the area of a circle. So that basically finds the area that's at the bottom. And just like with a stack of quarters, if you stack them up h high, then you multiply by h, and then that would be the volume of the whole blue area. And then because this one actually says the volume divided by the time, that means this one right here is saying the derivative of the volume with respect to time is equal to 200 cubic feet per minute. And I'm pretty sure I mentioned this last time, but always make sure that the units are the same. So feet and feet. Like if this one would have been given in inches, then you'd have to change it to 3 out of 12, so it'd be 1/4 of a foot. But this one is given in feet and feet, so we don't have to worry about that. Okay, that's the general formula. Now, if you have things that are not going to change, like for example, the radius is 3 feet. Well, when you fill this container with water, it's not going to make the container get bigger because it's made out of steel. It's going to stay the radius of 3 feet. That means we could go ahead and plug that in right now because it's not going to change. So volume equals pi, and then 3 gets squared times h. Or I guess I could simplify that. That would be 9 or 9 pi times h. Now take the derivative. Well, on the left side, that's just going to be dv dt equals the constant 9 pi will just sit there. And then I take the derivative of the h. So dh dt. Which is perfect because my question was, how fast is the water level rising? So right there, I was saying find dh dt. How fast is the height changing after 15 minutes? Well, when it's a shape that's constant, like this Gatorade bottle, or at least up to there, the shape is constant, it doesn't change. So the water level, if you're filling it at 200 cubic feet per minute, when it's right there, and when the height's right there, and when the height's right there, it's going to be changing at the same rate. But if it was something like a cone that's really skinny at the bottom, and then it gets bigger and bigger, well, at the beginning, when you're down at the bottom of the cone and it's really small, the height is going to be growing really fast. And when you get towards the top where it's really wide for a cone, then the height's not going to be changing very fast. So if it's a shape that changes as you go up, then the time matters. In here, the time doesn't matter. So this is not even needed. So all we need to do is plug in the 200 on the left side for the dv dt, and then we'll divide both sides by 9 pi. So it would be a 200 goes on this side. And the last step to solve for dh dt, it's going to be 200 divided by 9 pi. And that is 200 divided by parentheses 9 pi parentheses. So a 7.074. .074. And since it's dHdt, that means the top is the height, so that's in feet. And the bottom, according to this, or this, the bottom is in minutes. So this is in feet per minute. So obviously, I didn't really think about the numbers when I made that one up, because for something to fill up 7 feet in 1 minute, that would be a lot of water. But that's what we got. 11:53. Are there 2 more or just 1 more? Oh, just 1 more. Perfect timing then. So questions like this are good practice for, do you understand the first and the second derivative without actually taking the first and the second derivative? So to begin with, this part is just telling us some points on the graph. So when x equals -1, then y equals 0. And when x equals +1, then y equals 0. So that part is done. Then on to the derivative does not exist at those points. Well, there's several ways the derivative could not exist. You could have a corner like this. You could have an even sharper point like that, which is called a cusp. Or it could be that the function is not continuous. And at this point, I don't know what it's supposed to be. So what I'm going to do is I'm just going to draw a corner there and a corner there. And I might need to adjust it later. And then this one is saying when x equals 0, the derivative equals 0. So right here is x equals 0. And then this is saying that the slope of the tangent line equals 0. So that means that it's a horizontal line. And at this point, I don't know exactly where to put it. But since these two are sort of pointing up towards that, then I'll put it up there. Then on to the second derivative. So this part right here is saying the second derivative is positive. That means the shape looks basically like this. So this means concave up. And then that is supposed to happen on the left side. On the left side of -1, it's supposed to be concave up. So where I started to draw it, that does not look concave up. So I'm going to try to draw it a little bit better. Concave up would be more like this. And then this part, second derivative negative, that means that it's concave down. So it looks more like a frown. And then that's the middle part between -1 and +1. So then it's supposed to be concave down, more like this. And then right there at the top, the derivative would equal 0. And then also on the right side of one, it's also supposed to be concave down. So then I could just continue it like that to look concave down. So then I would just redraw it so that it looks a little bit better. So this part, oh, my pen is thinking I want a straight line, is concave down. The middle is concave down, but the left side is concave up. And then this point is a cusp. So that means the derivative does not exist. And then this one, it's not a cusp. It's like the right side of it is a cusp, but the derivative would not exist there. Because look, if you zoom in on that point, it would come in like this. So that means on this side, the slope would equal, I don't know, something like -1. But then if you look on this side, it's going up. So the slope would equal something like +1. Which means right there at that point, the derivative does not exist because the left side and the right side don't match.